So here we are provided with a trigonometric equation, sine of 2 theta equals to lambda times sine of 2 phi. We need to express tangent of theta plus phi divided by tangent of theta minus phi in terms of lambda. So let us begin. So here we'll start with our given equation. We are given sine of 2 theta equals to lambda times sine of 2 phi. Let's do one thing. Let's divide both sides of the equation with sine 2 phi. So we have sine 2 theta divided by sine 2 phi on the left hand side, and then on the right hand side we only have lambda, which can be also expressed in the ratio format as lambda over 1. Okay, now there is a reason why we are writing in this particular fashion, because in the next step we're going to apply the componendo dividendo method. So the componendo and dividendo method states that if we have two ratios, a is to b equals to another ratio, so a is to d, then this implies then we can do a plus b divided by a minus b, and this will be exactly equals to c plus d equals to c minus d. The ratio is still going to be maintained. Now let's apply the componendo and dividendo method. We're going to label this as number 1 to 1, so that 1 now transforms to, we have sine 2 theta plus sine 2 phi divided by sine 2 theta minus sine 2 phi, and on the right hand side we have lambda plus 1 over lambda minus 1. Now immediately we see that we have the sum of two sine functions in the numerator and the difference of two sine functions in the denominator. Out of the four, we can use the first two. Whenever we have the sum of two sine functions, so that transforms into a product of sine and cosine as shown here. Similarly, for the difference of two sine function, we also get the product of two cosine and sine given in this particular fashion. Okay, so let us apply the transformation formula. So for the numerator, since we have the sum, we'll apply the first formula. We'll treat 2 theta to be alpha and 2 phi to be beta, such that we get 2 times sine of angle, so 2 theta plus 2 phi divided by 2, and multiplied to cosine of angle 2 theta minus 2 phi divided by 2, whole divided by, now we have 2 times cosine of angle 2 theta plus 2 phi divided by 2, multiplied to sine of the angle 2 theta minus 2 phi over 2. So this will be equals to lambda plus 1 divided by lambda minus 1. So now we can factor out 2 from the numerator and the denominator. So this is going to give us sine of, so here we have 2 theta plus 2 phi over 2. We can factor out 2 from the numerator and the denominator. So that leaves us with theta plus phi. Multiplied to cosine of, similarly we can also factor out 2, so leaving us with theta minus phi. Whole divided by, so we have cosine of theta plus phi multiplied to sine of theta minus phi in the denominator. This will be equals to lambda plus 1 over lambda minus 1. Now here we have the ratio sine over cosine, so that's going to be the tangent function provided both of them have the same angle. Since in our case the angle is theta plus phi, so we will get tangent of theta plus phi. This will be multiplied to the ratio cosine over sine, which is nothing but the cotangent function provided they have the same angle, which is theta minus phi. This will be equals to lambda plus 1 over lambda minus 1. But we know that the cotangent function is the reciprocal of the tangent function. Therefore, we have tangent of theta plus phi. So we will take the reciprocal of the cotangent function. This will become simply tangent of theta minus phi, which will be equals to lambda plus 1 over lambda minus 1. So yeah, so we have successfully shown that this is equals to lambda plus 1 over lambda minus 1.